finish up dirigibles. And then we're going to get into the Wright Brothers Heavier Than Air section of the book. So I'm sure you all have read the book. And as a result of reading the book, you already know in advance, so you can take really good notes. Is that correct? So, what is a dirigible? We've talked before about balloons, and we've talked about blimps. Andrew? Well, the word Zeppelin, you know what that means? That's the name of the man who did a fixed and rigid airship. Yes, it's sort of got to be like the name of that kind of a ship, but that's not really the name of those kind of ships. They're airships. Some of them are rigid, some of them are semi-rigid. It's just like, you know, if you say, hand me the Kleenex, or I want a bowl of Jell-O. Those are brand names. You know, Kleenex is a tissue. Jell-O is a gelatin mix. And one of the problems that manufacturers have with products is that they don't want their products to become generic. Because if they do, they lose copyright, they lose patent protection. So just like Zeppelin lost that because he let it go so long that people were calling everything that looked like an airship, they were calling a Zeppelin. So the very first thing about a dirigible is it's lighter than air. And we'll be dealing with heavier than air. When we finish dirigibles, we're going to be getting into the whole concept of heavier than air, which will take us all the way through probably the end of the semester. Beginning, of course, with the Wright brothers, which will be our lecture tomorrow. Lighter than air, powered, and steerable. Those three things are the definition of a dirigible. So chances are someone in the future writing a test for you all might say, what are the three factors necessary to define a dirigible? And then you would very quickly write down the three, because that professor said that maybe it might be on a quiz or a test. So we had balloons that were non-rigid, weren't they? Filled with air. So balloons and blimps kind of in the same category, although the shape of a blimp is decidedly different from a balloon. And then there are semi-rigid dirigibles, meaning that part of the underside of the balloon, of the gas bag, has a structure that supports the gas bag. And then finally rigid. And what would be an example of a rigid airship? Pardon? No, give me a name. Hindenburg. Who said that? Raise your hand. Yeah, see, Hindenburg is an example of a rigid airship because it was structurally rigid inside. It had a covering on the outside. It was steerable, and it was powered. So it's a perfect example of a dirigible. That's one of them, right? Goodyear blimp. In this case, it's not filled with hydrogen, is it? What's it filled with? Yeah, helium. Looks like a big Russian one, doesn't it? Pretty massive. What were some of the early problems associated with dirigibles if you read the book? Pardon? Trouble steering, that's one. Correct. What's another one? No, they had power. The other one was hydrogen. Some of them used hydrogen. That was a big problem. But the third, and probably from a practical point of view, the third problem with a dirigible is that it was so slow, couldn't go anywhere. If it went into a 5-mile-an-hour wind, it would be hovering. Most of them were so underpowered, as Jacob pointed out, that they were, for all practical purposes, not functional. They just didn't have enough power to be able to go into a wind or go downwind and then turn around and get back again. So a number of them would go downwind and they would be forced to land somewhere and wait out the wind. This is an example of a dirigible being built with a frame structure. If you read your book, you realize that Giffard from France was one of the ones who did a first flight of a dirigible. They tried to power them with steam engines. They actually did get small steam engines involved in the actual use of the dirigible, but the steam engine generally didn't even have enough power, and you couldn't make them big enough because the bigger the steam engine, the heavier it weighed, and therefore with that extra weight, the dirigible really couldn't go anywhere, and had to be even bigger than normal in order to satisfy the extra power. But the bigger the airship, the dirigible got, the more drag, right? So now you had to have more power, but the more power you had, the more size, the larger the airship, the more the drag. It was a situation where in your cars today, if you look at the speedometer in a car, the car speedometer says 140 miles an hour, and I doubt that there's a car in the street, a standard car off the production line, not a sports car, but a standard car, that will never get to that speed. Because as you get faster and faster, what happens to drag? It increases as, oh, come on, guys. Remember we talked about that? How does drag increase? The what? Speak up. That increases, but what causes the difficulty of ever getting to 140 miles an hour with a standard sedan? Power. Pardon? Power. But what causes the power? What about drag? Didn't we say that drag increases as the square of the velocity? So that if you're doing, I know in my Corvette, for example, I was going to 71 miles an hour and it had 1,700 RPM. So that means that I ought to be able to get to 140 miles an hour at 3,400 RPM. But the red line was 7,000 RPM. I doubt I would ever have gotten maybe to 140, maybe to 150, but never over that. And it's because those speedometers are made by people who don't want to tell you that drag is a big problem. Drag is a big problem with everything, whether you're driving a truck, a pickup truck, a car, a kiddie cart, a bicycle even. Have you ever tried bicycling, pedaling as fast as you can possibly pedal on a bicycle, you realize the faster you go, the tougher it is. Because the wind is on you, but it's also drag, and it's increasing as the square of your speed on the bicycle. You can't get away from the fundamental law of nature that says that drag increases with speed, the square of the speed. So 6 miles an hour was a typical speed for a dirigible in those days. And so you can imagine, for example, trying to fly around the Central Valley here with a maximum speed of 6 miles an hour. Yeah, you can go downwind, but that's as far as you can go. So in 1852, there's a picture of a dirigible which is semi-rigid, means it has a structure below the dirigible, but the entire dirigible is not framed in any way. These are the various ways in which you can power a dirigible. You would like them to be electric. The trouble is that in those days the batteries would be so huge that they would be worse than a steam engine. Gasoline with propellers? Sure. That makes sense. As we talked about before, the main problem with the dirigibles are either steering, hydrogen, or speed. And I think you can probably identify that if I asked you a question, what is one important problem with an early dirigible? I would suggest that you would answer speed. Because when you think about it, that is probably the most functional loss that you can have in any kind of a vehicle like that. Because while it can go in one direction with the wind, it can't come back if the wind is 6 miles fast or 6 miles an hour or greater. So there are some key issues here that I want you to remember.